Hi, everyone. Welcome to this session. My name is Sheen Brisals, and I'm an engineering manager at the Lego Group. So this is Lego.com. I promise you this is not a sales pitch, but this is more like a technology pitch. What I wanted to say here is that Lego.com runs on serverless. So all the backend services, apart from the SaaS platforms, the third-party vendor platforms, everything is 100% serverless. And that's the reason why I'm here talking about serverless. And as part of our serverless implementation, we have over 200 Lambda functions and around 50 or so microservices, all serving millions of customers and helping them to place thousands of orders every day on Lego.com, all with serverless. So the agenda today is a brief one because this is a short talk. So I will briefly touch upon EventBridge if you're not completely familiar with, and then I will focus on a couple of key acceleration factors that will aid us to gain the momentum when we do serverless, especially with EventBridge in place. And then I will take you through an acceleration use case where a feature that we recently developed, where how we use those sort of the acceleration factors and to gain the speed with which we develop. And I'll leave you with a few takeaway points for us to remember. Right. So someone recently said every serverless talk should start with defining what is serverless. And I said, no, that's legacy question. I don't talk about it. But what I will talk about is why we use serverless. What are the benefits of few benefits of using serverless? It's an ecosystem of services. It's not just a Lambda function or a DynamoDB. There are a bunch of services coming together to provide us the serverless services that we use. And the beauty is the granular optimization option. So one Lambda function from the other, one table from the other table, all can be tuned to the perfection. This is the beauty of having serverless. And I always talk about the engineering diversity. So though it's not technically related, what I mean here is that we are not seeing programmers. Engineers are kind of understanding the architecture, understanding the security, being part of the DevOps movement. All those things come together to give a complete picture for the engineering team. And most importantly, it's an ideal technology for incremental development and iterative development. Keep note of this point. I will come back to this later on. Now, EventBridge is a simple event bus that connects, carries data from one application to the other application. That's in simple terms. But where and how we use EventBridge. So if you think this is your typical serverless ecosystem where you have number of services, and obviously they don't sit alone and do something. They obviously need to communicate. So there is a communication between number of different services, and in there you will find these sort of SNS topics sitting there and handling the sort of publishing and subscribing events and messages, things like that. Now, the thing is that even if you move those your services into microservices arena, you still have these sort of communication patterns all over the place. And you will find these, SNS topics basically pushed into these sort of different microservices. But the tangling of these communication lines still exists. So this is one place where EventBridge comes in. EventBridge kind of coordinates all these communications in the middle, acting as the coordinator or a choreographer with all these microservices. So that is the beauty of EventBridge. So what is EventBridge then? So at the core of EventBridge is the event bus. So there's a default bus, and we can have our own custom event buses. And then obviously on one end, we have event producers, the applications, the services, they keep sending events. You can think of all the AWS services that keep on sending events. And on the other side, we have consumers, number of microservices, AWS services can be assigned as target. And the power lies in between what we call the filtering and the routing rules. So here is the most important part of EventBridge, in my opinion, that allows us to filter and route the events to different targets. Now, So that brings us to what is an event then. So event is basically a simple JSON document. So there are two sections to it. AWS section, which has sort of few mandatory attributes, and there is a generous user session. This is where if you are kind of writing custom events, this is where all the details will go. I mean, there is no strict rule saying that it has to be this way or that way, but it helps to keep a structure. So in our case, we kind of format our custom events in this sort of structure. So that's an event, and you can carry any amount of data within the the limits of event size, but otherwise there is no restriction with what you can have in an event. Now, why we use EventBridge then? So 4 points. First one, it enables the event-driven architecture immensely. And because with EventBridge, we can decouple the services, and it has a bunch of good things that we can make use to make it really, really good with microservices. And the other thing is that this is something I like, because with the routing rules and the options I mentioned, we can really transform the incoming event to send just the data we want to the downstream targets, which is very important in this world of data privacy and PAI and things like that. And then, of course, as a partner event ingestion, also it enables the functionless integration. What I mean here is that it can remove the unnecessary logic being hidden inside a Lambda function or a different service. So we can eliminate all those as part of the rule settings within EventBridge. And keep note of the event-driven, the concept I mentioned, because this is another important aspect of what gives us the momentum with the serverless. So let's bring those acceleration factors that I mentioned. So the first one, of course, is event-driven architecture. So with event-driven architecture, and then on combining with that is the incremental and iterative development process that we have. So event-driven means, so we have microservices. They are decoupled or loosely coupled. So that allows us to develop these services in isolation, independently. They have their own pipelines and things like that. So when it comes to incremental and iterative, so we can start something very, very small and simple. And from there, we can slowly evolve iteratively. And every iteration, we have this sort of the completeness in place. We keep on adding new features. It's not like a typical waterfall where we start something now and deliver incrementally after 6 months. No. So every iteration is becoming kind of giving a good picture of the service or the feature we are building. So these two, in my opinion, give us the power to accelerate with our serverless development. Now, let's look at a simple case study where we can apply these sort of principles. So this is a new feature that we developed and about to go to production. So this is a back-end stock notification, very familiar. So customers coming on to lego.com looking for a product, then they see that it's out of stock. So but there is an option to register to be notified. So they supply the email, and email gets stored, and behind the scenes, there is a service that checks all the product status, and when something is become available, triggers a process and sends off an email back to the customer, and they can buy the product. So simple thing. Now, in a typical monolithic world, the whole thing will be built as a one service, monolith service, right? Now we moved on. So that's no longer the case. We can, of course, make it better. So what we need to do is we need to identify the parts within this sort of, the use case or the feature. So if you look closely, there is a customer registration part. There is a place where we keep the data. And then there is somebody in the, behind the scenes checking the status. And then there is a process that notifies the customers based on the emails. And of course, there is somebody to send all the emails as well. So now we see different parts within the whole, the feature. So the things become a bit more, clear, and, clarity gets in. So we can now start to think of different services and how we can make use of the data and the sort of the business analytics and the insights and all these things come together. So that will then give us the microservices view. So this is a simple view of, I just identified, the 6 different services that form part of this feature. So that's fine. So we have microservices, but then what happens? They obviously need to communicate, right? So because there is a dependency between these microservices. So if you draw the lines, that can go crisscross all over the place, right? Because without this sort of communications, these services are not going to come together to provide the backend stock, feature, right? Now, typically, when we think of these sort of service connections, we think of API gateway. Okay, so this is good, especially when we have synchronous calls, or you make a call and get an acknowledgement, then gets decoupled, right? So that sort of the typical use case we see. And then we have SQS. SQS is good for storage, buffering, and adjusting the flow of messages. But when it comes to filtering and sending off to different targets, it's kind of, it's a slightly different service, has its own different purpose. Now, of course, SNS. It's a very high powerful, high throughput, low latency, number of good things. But when it comes to filtering events, it's very difficult. You need to rely on custom attributes and things like that. People often call topic hell. It's because if you want to send a different event with a different structure, then you will end up creating a new topic. So that way, you keep on adding topic after topic every time you have a different event pattern or a structure. So this is where EventBridge comes in to give us this sort of the coordination, or what I call the choreographic point of view. So that kind of streamlines the connections between these different services. So how will it look like in an event-driven view with EventBridge in the middle? So this is roughly, you can think of all the the symbols or the events flowing from one service to other service. So you might think that, okay, yeah, that's fine, but how do I get the acceleration? How do I accelerate? So a few things. First thing is, think events as the contract mechanism between these microservices. So it's important to identify those events. And obviously, when you have events, you have, there is the schema behind it. And then identify these sort of independent microservices. They can function on their own. And then that allows us to develop them in parallels, because there is no dependency or hard dependency and things like that. So you have the sort of freedom to, bring up those services in parallel. And of course, use EventBridge to coordinate between these services. That gives us the flexibility to progress faster. So let's see how we can apply this principle in this simple sort of scenario I mentioned. So I just pictured 2 microservices here. So email registration part, notification part. The notification is the one custodian of the email data, because email registration doesn't hold the data for different reasons. So how does it work? So basically, if you think of events, so email registration service would send an event saying that, okay, here is a registration request. And then that goes to the other service that subscribes to that event, and it does its job. So, and there is a response coming back, and it's going to, not necessarily only these services will subscribe to those. Any service that has an interest in this the data float around can do that as well. So here are the 2 different events we can think of. Now, how does it look like? So email registration in simplistic form, it's an API gateway endpoint backed by a Lambda function, for example. Okay, all it needs to do is that once it receives a registration, create this event, push up to the bus. It doesn't care who are the consumers or where this goes. So that is the beauty of this sort of independent service development. This service on its own can be developed and deployed to production without even having anything behind the scenes, for example. Or you can even deploy to production with a feature flag set so that it's up and running in production, but still nobody can see. So that's sort of the flexibility we get, because all it's doing is that, so in this case, it's a back in stock event. It could be any event, right? So the right-hand side, that's a like example event structure. So that's fine. Now, how does it get to the other end? So on the other side, you have consumer. You have to set up a rule to filter the required events and then send off to the target. So in this case, that's microservices acting as the target to this event. So I show here is a simple filter. So this is a simple filter. It's saying that, okay, if an event comes from this service of this type, then yes, send to me or something like that. But the event filtering can be really complex, and there are a number of good patterns that we can put in place if you wanted to go fine grain, sort of filtering. So this is, it's good. So now the other service then works with the data. Now, there are a number of other microservices. So here is a product status check service. How does it come into this picture? Now, if you think this is completely a separate, a different service, irrespective of whatever happens with the email registration, it has its own job of keep sending product status events. So something out of stock, something back in stock, something, it's retired or whatever. So it again doesn't care who the consumer is. Whereas in this particular case, there is a consumer looking for product becoming available related event. So that's the notification process. So again, there's a product status, there's a filtering. So here is a sample event where it tells that a product is now available. It was unavailable or sold out previously. So the consumer is, yeah, we know that. So there is a filter which saying that, okay, from this service, this sort of parameters or values, yes. So what it now happens is that, so there is a step function as part of the service. So this particular event is targeted for that step function within that service. So that then gets executed, and the process of sending, fetching details from the DynamoDB store and sending off to customers via Amazon SES, comes into life. So this is how we can simply see the benefit of this sort of event-driven nature of choreographing with these microservices, and where the Amazon EventBridge really gives us the ability to take it to a faster route. So this is exactly what I meant by the acceleration. So here are a few example events. I mean, you can imagine there'll be a number of events. So I just picked a few as example. The point here is that, okay, now we can say that, okay, there are a number of events. How do we control these events? Like if the email registration service for some reason modified its event, is it not going to complicate the filtering or the routing rules set up on the other services? Yes, it can. And that's why we have, as part of EventBridge, we have something called the schema registry. Now, if you look at EventBridge, there are a number of schema already loaded. They're all for the AWS events. We can also create custom event for the schema for our own events. So we can really make use of this schema registry as a place to validate the events before we take these things into production. I mean, up until now, the schema followed the OpenAPI standards, but now they added support for the JSON schema as well. So this is something really will be useful as you start adding more and more events to your serverless ecosystem. So this is another important aspect to look into if you are into EventBridge. This really helps to make sure that you're not unnecessarily breaking downstream consumers. So here is a simplified picture of the architecture for the feature I mentioned. As you can see, as highlighted, the EventBridge is there as a choreographer between all the different microservices. And if you want to know more about the things I talked about, so here is a blog post I wrote a while ago, and it talks about the different services and how the the event-driven nature of developing such a microservices architecture works. Right. So that comes to the takeaway points to wrap up this talk. So what I want to leave you with: think in parts, think in set pieces, I would say, think in microservices, because that allows us so many good things like a loose coupling or independent development, parallel development, and all the good things that comes with the sort of microservices thinking. And think incremental in iterative development. So I talked about this something, you start small and evolve or scale fast and things like that. So this is really good, and especially with the serverless services and the technologies we have, it really makes it possible to have this approach. And every iteration you improve and you evolve. So this is really good thing to keep in practice. And of course, automate everything. Wherever possible, automate the deployment pipelines, automate them, and keep each service have its own deployment pipeline. So that way you're not relying on something else to deploy as well. So if one particular service change, you can just deploy that service and get going. And think of the best practices, especially when it comes to security. AWS well-architected framework, serverless lens is very, very important as we move faster with serverless, and of course infrastructure of code. And above all, think in events, think event-driven, and think, of course, EventBridge. When we think all these good things to take us, faster, obviously we will be thinking acceleration. Okay, that's all I have today. Thank you so much. Let's accelerate with serverless. Thank you.